Hi guys. I just wanted to make this video today to kind of help you out with some of the concepts we've been talking about in class. I know that I had a lot of people approach me after class the other day that appreciated the diagrams and wanted to kind of see a few more of them that I had from when I was in Bio 181. So I wanted to go through and not only show you those, but kind of teach you a little bit about concept mapping, which is one of the most helpful ways you're going to study for this class. To be honest with you, all of the bio classes I took before I switched majors, I had to concept map everything in order to kind of better understand it. So I'm just kind of calling this study buddy because this is study buddy for test one. Maybe I'll make more for the next tests depending on concepts. We'll see. But yeah, so for this study buddy video, we're going to kind of start concept mapping for the first time. So today, I'm not going to go over every concept we've learned. I'm just going to give you a few of them. I want you to do the rest on your own. But the way I like to start my concept map is I like to start by going to the very top and writing like Bio 181, test one, because that's where we're mapping today. And normally I'll put it in like a little box or I'll highlight it, whatever you want to do that better fits your vibe. Or if you're like really OCD like me when it comes to any sort of notes, you'll probably do like a box. But yeah, you've got, goodness gracious. Okay, we're gonna pretend like that's perfect. But what I'd go from there is I'll be like, oh, bio. What is biology? Well, biology is the study of life. We can go in different directions. Like I know we talked about medicinal plants. So maybe you see life and you're like, oh, I'll tie this into medicinal plants. And then you can keep going on in that direction. I'm not going to go into the medicinal plant stuff today. I feel like that's something you can do on your own. We're going to study more on the cladograms aspect of everything. So we're going to go down here. We're going to start our cladograms. We'll tie that into life itself because cladograms is kind of how we figure out what life came from what life. Cladograms. Whoa. Sorry, y'all. But yeah, so I'm gonna kind of, as you see, I have this graph kind of already started out just because it'll take me forever to write it. But the first thing I think we really need to talk about with cladograms is we need to talk about homoplasy, synapomorphy, plesiomorphy, and symplesiomorphy. So what I'm going to do is, in our case, you're going to write this down. I'm going to copy paste because I've already made 4 of these. So I feel like I got it in my head. But yeah, so we've got our graph right here for all of our concepts when it comes to traits and cladograms. And this is specifically thinking about like traits. So if you want to kind of add a highlight that's like, oh, gonna do, if you want to kind of go and be like, traits, and put an arrow down there. That way it kind of follows better in your concept map. I did not mean to zoom in so much. Oh my goodness. But yeah, so kind of going over it for definition for homoplasy, it's a similar trait that does not come from the common ancestor. I put down there that you can also abbreviate common ancestor as CA. I normally have like a key of my abbreviations in like the top corner, or I'll make sure to like note it down somewhere that, hey, that means common ancestor. Synapomorphy is a derived characteristic that's shared by the members of a clade, but not from the common ancestor. So the difference between these two things is, what I'll show you is down here, we're going to draw a clade. We'll get to the helpful hint next, but we're going to draw the clade. It's going to, like that one might have it, but that one won't. That one doesn't either, but that one does. So as you can see, like for this one, it's not shared by the members of a clade from a point on. It doesn't evolve in kind of like a simultaneous form. What I can show you too is there's sometimes when we do clades, we have kind of the circles in here as well to show what it evolved off of. And so one thing that helps me is looking at that and it's like, okay, so the common ancestor, which is this guy right here, doesn't have it. These guys don't have it. These guys don't have it, but this one does. And they're on completely different ends of the cladogram. So that means it's probably evolved from some sort of environmental factor. It's not necessarily evolved and stayed. Now, for synapomorphy, what we're going to do is we're going to draw the same thing basically, except we're going to, I always draw my line first and then erase my little circles. That way you kind of have a better, like a prettier clade. It doesn't look like it's all over the place. Because if not, it's going to look wonky. So for this one, since it's derived, so it means it kind of like derive, it comes eventually, like somebody eventually evolves it, and then they kind of continue to carry it on. So say like this guy right here evolves it, these guys will have it, and so oh, I forgot it deletes my circles. But that guy has it. So these three have it, and so that way it's synapomorphy because it continues and it's connected in the clade. The ways I like to remember these is homoplasy. Plasty sounds like plastic. And so you think of like plastic surgery, which doesn't give you the same traits that you've got. Like it doesn't give you a trait that you got from a common ancestor. So I always put like plastic surgery traits or that equals traits that don't come from a common ancestor. Or I'll say like aren't ancestral. The great thing about concept mapping is I don't always get too descriptive with it unless there's a concept I really don't understand. The more detail you need, the more you put. But yeah, and I'll underline the plas part so that way we can be like, oh wait, there's plas. We got like plas right here. And plas right here. Synapomorphy, I think of kind of as I described in class on Thursday, like synapses in your brain. You kind of form those and keep them. These traits are something that are formed or they genetically mutate or however they come about. They are formed and then they keep them in the newer generations. Moving on to plesiomorphy and synplesiomorphy. Plesiomorphy is that characteristic that's found in the common ancestor but isn't found in the newer generations. So we're gonna like oh, is it not gonna let me do a line? What? Come on. I believe in you. Yay! So like a few of them will have it. But then eventually as you go on, the trait's lost. So if you think about it, it's kind of opposite to synapomorphy, because synapomorphy is something that's new. Plesiomorphy is something that's old. And so kind of thinking about it being old, I think about like, oh, I would hope my ancestors would be pleased with me. So yeah, I think that's I think that's the actual sentence my TAs used when I was there, when I was a student in Bio 181. So I enjoy kind of like making that connection. So yeah, so if you say like, I hope my ancestors would be pleased with me, try to write fast, but then you're not gonna be able to understand my chicken scratch. So I'm writing slow, y'all. Bear with me. And then you kind of like underline that please, so that way you understand like, hope they would be pleased with me. That's the easiest way to remember it. And then for synplesiomorphy, it's a trait that's so basic or common, it doesn't give us much info about the ancestry. So it's basically, it's in the name, like simple is in the name. And so you think of like, it's so simple, it's not helpful. And so, yeah, you would think it's something, goodness gracious, I gotta draw again. So we're gonna do a little crab here. Please forgive my crab. He's going through a lot. So you got a crab, and you've got, we'll say, okay, well, I was so bad at art class in high school, y'all. I literally failed because she thought I was trying. So please bear with my art skills. There is a reason that I don't draw very often. But as you can see, we've got the crab and the cow, and they both have eyes. We'll use a different color. Or we'll just kind of like they both have eyes. But that doesn't tell us much because a lot of animals have eyes, and obviously the crab is a crustacean and a cow is a mammal. And so it's a ruminant. And so it's like it's not going to help us out if we're trying to build a tree because you can build a tree with a cow and a crab, but you're not going to get very far. Or you're going to get far, but you're going to have a lot of things you're going to have to put in between. And so, yeah, that's kind of it for the graph that I drew. This is the same one I drew in class on Thursday, by the way. But if we kind of want to go back to cladograms, I'm going to take a different color. Another thing with cladograms we're going to want to talk about is monoperic poly. So I'm going to draw an arrow down here. And we're going to need to talk about like structure and just understanding clades themselves. So over here, we're going to go down to clades. And so I'm going to come over here and I'm going to copy paste my little trees because it will take forever to get them right. Because once again, drawing on the iPad, I'm a perfectionist. And so, yeah, so first things first with the clade, what I want to talk about is what is a clade? I mean, what on this tree can be identified as a clade? And so for it to be identified as, we're going to kind of have a red no and a green yes. And so looking at this, you have, if I were to look at kind of this guy right here, that would be a clade because you're drawing from the ancestor and you've got everything above it. So that would be a clade. I'm going to delete this yellow around it, delete that green. Oh, I forgot I'm doing the part eraser. Forgot to change my eraser. Getting used to the new app still. But yeah, so we'll just circle. We'll change the color back to the pen. And then we'll circle this and say, because yeah, that is a clade. However, if I go through and I'm looking at this one right here and this one, oop, this one right here and this one right here, and we're looking from like here up, that would not be a clade because in order for that to be a clade, we would need to include all of this. We would have to basically, if we wanted both of those in there, we'd have to include the whole thing because this goes from this ancestor up, this goes from this ancestor up, but they're not connected and they're not showing us like they're not showing us everything above a certain common ancestor. So if we're going to try to do those two together, we're going to box that in as a no. But what about this line right here? If I wanted to include this line, what would that be? Well, you're including where like where it goes from like the one ancestor up, you're including the branch up. So that would be a clade. It'd be a very small clade, but it'd be a clade. So yeah, that's kind of how to determine clades. I'm gonna move this no and yes. Oop, gonna move it. Whoa, why is that connected? That's crazy. There we go. I'm gonna move that no and yes in there. And then we're gonna draw another one because we need to talk about different kinds of clades now. So we have, if you can remember, we had several clades we talked about. We talked about monophyletic, polyphyletic, and paraphyletic. So I'm going to actually change these colors up here really quick because I know we've been using the same colors a lot and that can get confusing. Obviously, if you only have like 3 colored pencils or whatever, you can do what you need to do. Just try to change it up if you can at some point or another, just that way you're not confusing yourself when you're going back and looking through and being like, well, why is Symplesia, Morphe, and paraphyletic connected? Because they're not. You just want to make sure the whole point of this is to make your studying experience either. But so we see no poly, they all end in phyletic. So what I'm going to do is just kind of draw down to, we're going to move this over. I'm going to pause briefly. All right, now that I've got it a little bit prettier, we're going to think of mono as one clade. Mono means one. We have poly, which means multiple. And one mistake I've commonly seen like people ask me throughout the years is like pair of, was that just two? Because it's a pair of, and it's to me the way I remember paraphyletic is para kind of sounds like part of, not pair of, part of. So that's kind of what I put in parentheses here is part of, because you say it fast or you like try to like cut it off or you say it in accents like it's parta, para. It's part of the clade. And so kind of highlighting this, mono, we would just be like, oh, this is one clade, that's a monophyletic clade. Poly would be multiple clades. So if we included all of this and this here, if I can get the circle to work, we included all that and the one right here, that would be a paraphyletic clade. Or a polyphyletic clade. Sorry, y'all. I was like, wait a minute, I'm doing that wrong. As I did in a different order than I normally do. And then para is just part of. And so if we included like this part of this without including both like branches, that would be part of the clade. So it's not the full clade it's not the full clade itself. And so what we're gonna do from here is we're gonna kind of talk about, I don't want to like do too much because I want y'all to do some of this on your own. But I also know that one thing that gets commonly confused is if we look at homoplasy again, we're gonna use that pink color for fun and also because I like pink. We commonly mistake homology and homoplasy. I'm actually gonna bring that up here. That way we have more room. But homology and homoplasy and homology is traits we like, and it's genetic and it's kind of like figuring out stuff with DNA. So with homology, you're thinking of the more like official sciencey, non just eye observable stuff. And so I kind of think of like, oh, I spelled that wrong. How did I spell that wrong? Oh my goodness. Homology sounds a lot more like official, sounds a lot more sciencey. So I kind of think of it back when I did this, I was like, oh, ology. Ology is like science of. And so we think of it being science of, we think of traits and it kind of being more the science behind traits, and science behind traits and figuring that out is typically genes and evolution and all that. Meanwhile, homoplasy is got that kind of, it sounds once again like plastic. It's the less official, more observable. It's something that's derived due to more environmental traits and not because of an ancestor. Being plastic and like plastics taking over our environment and how there's tons of plastic in the ocean. Kind of think like that, even though it's a depressing way to think about it. And I know we talked a bit too about kind of classifying organisms and kind of embryonic genotype, phenotype. And so I'm going to challenge you to pause. We're going to write down, once again, embryonic, genotype, and phenotype. I'm going to challenge you to pause the video. And I'm going to pause it on my end, and I'm going to draw out what I want to, what I would do to kind of map this concept. And then you're going to draw out what you're going to do to map this concept. And I want to see if it compares at all. Okay, so as you can see, I kind of made a generic kind of classifying organisms tab, and then I put type under there. Embryo is obviously embryo. I don't know why it said embryo. It's not an embryo, it's an embryo. This is like a little brother. You can call him your embryo. I don't know. But embryo development, genotype is genetics, and phenotype is physical. Genotype, you remember like that pheno, you can remember the p. And then you can kind of talk about like naming organisms and like writing the scientific name. I know I've done that in the past ones. Talking about like the process of naming and classifying. So like systematics, taxonomy, all of that. We need to include that. I also figured it would be best to mention orthologs and paralogs as well, because I know a lot of people get those confused. And I know I did have a little orthologs, paralogs thing in class, but I would definitely recommend putting like a doodle in there, like orthologs, they kind of go to the same, like a similar place. Paralogs are like different spaces. So I would recommend doing something like that as well. But that's kind of a good example map. I know I've done a ton of these to just kind of like perfect it, give y'all the best one. As you can see, that's the one I did in class. That's the one I kind of did to be an example, to be my reference point for this. So yeah, I mean, sometimes it takes several tries. The best thing you can do is to make a concept map and go back through it and try to fill it out, or try to kind of better understand what you need to do. It's going to be really helpful for you to kind of fill things out. My mom's trying to figure out grocery stuff. Sorry, guys. But it's best to kind of fill it out and then try to be able to recall it from memory, do that recall technique that we've talked about as well. I'll also attach a video I did for previous class about the best way to study and the best study techniques you can use, just so that way you kind of have those to reference. If you have any questions, please feel free to email me. I didn't write it down up there, but as you can see, it's just KAECKHOF at ncsu.edu. So if you ever need to reach out about that and any sort of study techniques, if you want me to double check your concept map to say like, hey, does this look good? Do you think I'm doing this right? Please feel free to reach out. But I hope this video helps. Good luck with test one. You've got this. It's gonna be great. You're gonna do great.